Okay, so this is just a short podcast on using LLMs to write Python code. So what I'm going to talk about is how to use AI LLMs for coding, to show you some of the issues with prompting, and then at the end just give you some of the kind of warnings. One of which is if you use the LLMs too much when you learn your code, you probably won't be using them as effectively as you should be, and then also some kind of policy issues. Okay, so we read in the popular press, some people like the head of NVIDIA are saying soon we're not going to need software engineers because these large language models can actually write code. So what a large language model does, it just trains, it has a whole bunch of parameters and it trains itself on big repositories of code and it just fits its internal parameters and it can predict how to write code. And also the famous examples of ChatGPT from OpenAI, Gemini from Google. The advantage of the Gemini integrates well with some of the Google tools. Microsoft Copilot, that's from Microsoft, and that integrates with some of the Microsoft programming tools such as Visual Studio. Okay, so obviously there's some key issues with this. You can ask one of the systems to write code. One of the issues is the resulting code correct? So you do have to test it. And actually, if you're going to use this a lot, if you're working in a job day to day, you probably don't want to just paste from a web page. You want to be able to sort of integrate these tools, these large language models, with editors such as Spider, and then it's more sort of integrated in. And some of the tools are starting to do that. And one of the issues with maybe not so much for codes at university, but the large language models will produce code snippets, maybe 100 lines of code, and actually bigger programs is how do you connect all these small snippets of code together to make a kind of coherent program. Okay, so fast-moving areas. So I have read this book. There's a book there, Assisted Programming for Web and Machine Learning, that has examples of using LMs to write, sophisticated machine learning models. But obviously, sort of rapidly moving situation, and these AI things are being updated all the time. So I was listening to a podcast, and he was claiming one of the LLMs will write code, then it'll run it somewhere, and if there are errors, it'll then modify the code again to try and get it to run. So these things are getting more and more sophisticated. Okay, so there's now something called prompt engineering. Essentially, when you ask a question of a large language model LLM, you're entering a prompt, and the way you ask the question will change the prompt, will change the answer you get from the LLM. And they've introduced a new discipline called prompt engineering, where if you change the question of the LLM, you'll get slightly different answers, and that will affect how good the results are. And in fact, with some of the new large language models, you can ask a question, then you can modify the question again, and you can ask for code, then ask for it to be updated. So an example of problems might be write Python code to do X, where X is solving some problem, but you can ask for it suitable for a person learning to use Python. So that means that it shouldn't just use something too complicated and sophisticated. You can also input code and say, uh, ask it to write it faster. Obviously, you can do things like if you get an error message, you can ask it to find out what the problem was. And on some of these tools also, I have tried, I'm not going to show in this demo, you can say, take a Maple code and ask for it to be rewritten in Python. Okay, so I'm going to do some demos, and I'm going to use Google's Gemini ML large language model to write code. You can use whatever you want. Uh, and the advantage the Gemini, so I've used something called Google Colab, which I'll show in a minute, which is a website that you can run Python. You can run the Python on the Google data centers, essentially communicate with a web server with a via web browser, You write code in the web browser, and then the code is actually run on the Google data centers, and the Gemini large language model sort of interacts with the Google Colab quite well. So it's quite a good kind of workflow to saying these things. Okay, but I just want to stress you can use whatever tooling you want. Okay, so just okay, so I said Google Colab. There's a web page, and you interact with it via the via your Google uh, credentials. You can create a new notebook. So it's using something called a Jupyter interface. So you can type in the boxes. Let me click on this. So it's essentially a Python interface. It's a bit different to Spider, and it's here running in the web page, and all the code stored uh, in your Google Drive. You can actually generate code. There's the Gemini, which is there. So sum up. Okay, so it's actually generated some code. So you put in the text prompt and it's generated some code. And instead of having to cut and paste, it's ready to run inside the Google system. Right, I guess we should check it. Uh, we checked 1 to 3. Okay, so numbers are 1 to 3, and that's 6. That's giving me the correct answer. Okay, so within the Gemini, so within Google Colab, you have access to the large language model, and so it's kind of quite a convenient way to code. You can also just bring up the external code. Um, so we can write the same prompt. Okay. Okay, so I didn't ask it to write Python code. It's giving me the analytics formula, and then there's a little dialogue. And it's actually uh, so this time it's actually produced the formula, and then it's produced some test cases. You can actually, if you go down, so if you feel work on the data, you can actually click on this title here, and then it'll export to Google Colab. So you get it directly into the Google system. Okay, so stable version there. You can uh, you can iterate a little bit. Okay, so it had a whole bunch of test cases before, which was kind of, I mean, test cases are normally good, but here, if you just want the code, you might want something simpler. Uh, Use price, so you write a faster version. So you can see, using the prompt engineer, I can iterate. Okay, and it's telling me there's no faster way to do this. So, and then it's giving me some ideas. Uh, okay, so, and this is then we have to contest it. So object precision, so usually there's restrictions on how large integers can be, but sometimes in software you can actually, if you want to run with 20 trillion or something, you can use software. You'd have to really check what it's doing. So you can iterate all this and write new versions of the code. Uh, you can ask the system to, uh, so here I'm going to ask the Python code to load in face.png and plot it. So I want to do some sort of maybe some analysis of an image, and I want to learn how to load in a PNG file. Okay, let's produce some code to do that. Then it does some explanations. I can copy code. Uh, then I can bring up Spider. Okay, then we can paste from the code in. One of the issues we have is it needs to know where the face.png is, and sometimes you have to change the default path. So I pasted this in from the LLM. Okay, I'm going to save the file in downloads. Okay, took a while to run. So one of the issues is you have to make sure it is uh, that it knows where the document is, and then when I run it, so here the AI has written some code to actually load in this image and then plot it with matplotlib, and then this could be you could use for sort of machine learning or something. Okay. So that's the sort of power of these things. It's faster than doing a Google search. It does generate examples. So some of the issues we have to be careful of. So I'm happy for you to use AI to generate code in this module. In other modules later on, you should really check what the policy is. Individual lecturers will have different policies. They should make it clear. An important issue is my understanding is many of the big tech companies actually lose money with these free tools, and even with the paid tools, like the Microsoft Copilot, they might charge $20 a month, but it costs them $30, so they're losing money on all these things. So it may be that we do lose access to these tools. And I was reading about somebody who set a deadline for coursework, and then ChatGPT went down for 2 hours before the deadline, so a lot of the students were uh, having problems. We should also be aware that these AI tools use a lot of energy and water. Energy is a big issue, and also water is a big issue for cooling. So, it's not entirely environmentally safe to use these tools. Although some of these LLMs can speed up, it can do things as a multiplier. There's something called a myth of a 10x developer that there are books where people have run competitions, and some organizations can write their software sort of 10 times faster than other people. There's a review there when you look at the slides. Uh, but that's actually a lot much bigger improvement than actually using a large language model. So somehow still humans are actually much better than the best humans are still much better than a large language model. So they don't, what I've read, they don't speed up performance by factors of 10, but they can improve the productivity of standard people who are doing code, particularly if you're just using code to solve problems rather than being a developer. And the other thing is education, which is worried about, is cognitive offloading. Just means that if you use the AI tools too much, you don't learn some of the uh, some of the tricks of the trade of using programming to solve maths problems. So we're still learning what the best way is to teach these things. Okay, so that's just an insight into using LLMs to speed up Python programming.